Okay, this has been following on from the Slayer Exciter experiments, and also sort of merged with the a bit of the Capogen stuff, the Tariel Caponanze. What I've got here is an MJE3055. We're standard sort of Slayer Exciter, really. The resistor there is a 2.4K going between the base and the collector. The base is going to this primary coil here. I've got to watch it because it keeps shocking me. That is 9.5 centimeters high, 5 centimeters wide, and there is approximately 28 turns per centimeter. So I'll let you work that out. We're running it off a 12 volt DC, an antique 12 volt DC power supply. And this is a 240 volts, I think that's a 25 watt from memory. I don't want to pick it up in case it shocks me. Basically, we're just coming off the top of the primary coil, which is just connected to the base. That usually just let run free. We've got one side of that going into the bayonet cap for the lamp there. And the other side is just sitting over here doing nothing, kind of acting like an aerial. When I pick it up, ow. So it's not that. It's not, and I've just dropped it, and it's earthed now, and the light's gone out, but the circuit's still running. A metal bench, of course. You can see the plasma just streaming off the end there. So, yeah, I don't know if it's really that efficient. I mean, that light's not that bright, and we're talking about, I'm guessing this is over 1 amp draw. I haven't got any amp meter measured on it because my amp meter only goes up to 1. I might hook this thing up to it later, see if we can get it an accurate amp draw. But yeah, that's it so far. Interesting. I mean, this is also sprung out of the SEM77, which is also part of the Capogen thread. And SEM77 has actually got a I've tried this and I'm not getting much different sort of results, but he's just got a sort of a split copper pipe sitting down, so it's split down the vertical, sitting inside the coil, and then he's got a piece of ferrite on top of that, inside that, and then he has that bit of copper pipe actually then hooked up to a third coil which sits around the top. Now I've tried various configurations of that, and I'm yet to see the sort of results that he's been seeing. Mind you, we don't know what sort of coil his primary coil is. We think it's 7 centimeters by 1 centimeter, but we're not sure of the wire gauge. It looks pretty fine though. It looks sort of 0.2 millimeter or something like that, I think, which is why I've been disassembling a tape motor today to grab the wire out of here for one of those. I guess this is the first time I've seen an incandescent globe like this run off the one wire. I know other people are sort of doing them wirelessly as well, but if we can get a closer look at that, I don't think there's much heat coming off it. Oh yeah, there's a fair bit of heat, but you know, if it's at 1.5 amps, which I suspect, or somewhere up around that range, and we're running off 12 volt, well, I'm sort of saying it's, you know, up around 15 to 18 watt or something, and you know, it's a 25 watt globe that's not fully lit. So the only interesting thing for me, I guess, is that it's doing it with one wire through these longitudinal waves. So hopefully that helps a few people out there with their replications and what's going on, but that's been my experience. One thing I did find that gave me more voltage, and someone mentioned this in the Overunity thread, is to get the transistor much closer to the coil and have your leads much shorter. So that's certainly what I've done there, and I did see that brightness go up. My next thing I'm going to try with this is seeing what I've tried this on a virtual earth, but you know, even just hooking that lead up to it sort of gives the same effect as a virtual earth. If I come over here and stick this to the vise, it basically, the light just completely goes off. So it just seems to work pretty well as a aerial. Anyway, I'll let you know how I go with the next set of experiments.